I just wanted to say, introduce myself first. My name is Marta, and I am a business development representative here at MariaDB. I am based in London, but I cover the Southern European region, Eastern European. I cover the whole of Africa. That's part of my territory, as well as the German-speaking countries. And after this presentation, you can contact me for any of your enterprise needs or questions that you may have. Alongside me is my colleague Kester, who is our amazing senior solutions engineer for the EMEA region. And he is here with me today to have a conversation about high availability and scaling within the enterprise cyber. Before Kester joined MariaDB, he was an experienced DBA, and at MariaDB, he has done many technical roles, including enterprise architecture, consulting, training, and sales engineering. So we have a real aspect in our hands. Okay, so usually when I talk to my customers and people looking to move to MariaDB, one of the most common needs and ask questions is, how can I make my deployment highly available? It is clearly something that is very important among different niches and use cases. So I was wondering if perhaps Kester can tell us a bit more about how MariaDB solves this problem.
Hi everyone, and thank you, Marta. For those of you who have used MariaDB or MySQL, you will be familiar with replication. Normally, asynchronous replication. This is where your transaction is committed to the primary server, and then the transactions are written to a binary log and transformed to the replica or multiples of replica servers.
So when people say they are using replication, is this what they normally mean, Kester?
Yes, generally. So when people are using replication, this is what they mean. They could be using semi-synchronous replication or maybe clustering instead.
And why is replication useful to customers?
Well, the primary use is to create copies of your data on another server.
Mhm.
And these servers might be used for running reports or taking backups. And sometimes they're used in case of a failure of the primary server. In fact, there are many things you can do with replica servers.
Okay. Am I right in thinking that sometimes people have the replicas in different data centers or clouds?
Yes, yeah, this is correct. Replication can be used to move data into other locations for maybe disaster recovery purposes. They are also sometimes used for offsite backups and to put data maybe closer to the application so people can get faster reads.
And how many replicas can you usually have?
Really, there is no limit or not a limit that people will get close to. Sometimes you will have a replica of the replica. So these can be chained together to make various different configurations.
Hmm. Okay. So before you mention semi-synchronous replication, Kester, what is that exactly?
Well, semi-synchronous replication is very similar to asynchronous replication, apart from at least one of the replicas is configured to acknowledge to the primary server that it has a copy of the transaction in its relay log. So it's guaranteed to get to the replica.
Okay. And why will people use this exactly?
Well, the main purpose is to ensure that you have a replica that is in sync with the primary database, but
Mhm.
it can add a small delay to the transaction processing speed.
Okay, I think I'm starting to understand. So what about a cluster?
Well, a cluster is where a minimum of three servers are working together. So all of the nodes in the cluster are kept in sync with each other, and technically, any server can be written to or read from.
Okay, and does it need to be exactly three nodes?
No, not at all. Some people use five or seven or nine, and sometimes even more.
Mhm.
It is also possible to use two, but then we need to use a technology that we call an arbitrator.
Okay. So why would people exactly use a cluster?
Well, a cluster is a very good solution for high availability. It helps to ensure that all of the nodes in the cluster are always consistent and they all have the same data at all times.
Okay, so can these servers be in different data centers to maybe help with high availability?
Technically, yes,
Mhm.
but it's not always a good idea. The speed of the cluster is impacted by the latency of the network. So, generally, the closer the nodes are to each other, the faster they will perform. The clustering technology does allow for what we call network segmentation, and that allows to help run the cluster over larger distances.
Okay, so am I correct in thinking that sometimes people have clusters in different data centers like Singapore, London, or New York, or Johannesburg?
Yeah, this is correct. And then generally, they are linked together with asynchronous replication. So, in this way, we can use both technologies depending on the customer's requirements. The exact solution will depend on what the topologies are that are required.
Okay, so I guess this is why we would usually recommend customers to work with us on creating this solution first, right?
Absolutely. There are many solutions and technologies available, and the best solution might not always be obvious. Working with our experts before implementing new topologies is always the best option, but of course, we can help companies scale their existing architecture as well.
Hmm. I'm glad that you mentioned scaling actually, because usually when talking to our customers and different people who are looking to move to MariaDB, I often get asked a lot about the different scaling possibilities we have.
Well, there are many different types of scaling. So, vertical scaling is when you add more resources to your server, maybe more memory or CPU or bigger or faster hard disks. But sometimes this is not always possible or even the best solution. So, we work with our customers by scaling horizontally and we can add new nodes into your solution. And this is generally the best way to go. So, when you add new nodes into your solution, it allows the workload to be separated or distributed over multiple servers.
Okay, so I think, is this what people call read scaling?
Yes, this is part of it. If you can offload the reading of data to multiple backend servers, then you reduce the demand on the primary server. So this works best in a asynchronous style solution. People do not always just scale the solution by adding more nodes. They sometimes scale by creating a smaller cluster of servers. Each of these smaller services are dedicated to a different business area. So, for example, you might have a cluster for your products and your invoicing and your orders. And on their own, each of these can also be scaled. Now,
Mhm.
this is sometimes known as sharding, and there are various different ways to operate sharding. MariaDB, for example, has a storage engine that we call Spider, and
Mhm.
that allows you to locate data that is related to a particular table on multiple different servers. And we also have a product called MaxScale that provides sharding capabilities.
What can you tell me about MaxScale? Because I know that is our proxy server, but from what I understand, it is much more than that. I think I'm quite aware that customers use MaxScale for many different purposes.
Well, yes, as you say, MaxScale is, at its most basic level, a proxy server. It
Mhm.
distributes your workload over multiple backend servers, but it is a great tool for scale and high availability. So
Mhm.
MaxScale speaks database, it speaks the database protocol, and therefore it knows what is going through it. Unlike other load balancer systems, it does not just distribute packets over servers. It inspects the packets of information and can, for example, split or read and write transactions. So
Mhm.
this is normally the first thing that companies try and do to help scale their database layer. With max scale, you can automatically do this for you without having to change your application.
Okay, I think I'm starting to understand it a little bit better. So you're saying that companies can scale, read, and write without making any software changes.
Yes, exactly that. So with some simple configuration, MaxScale will distribute the transactions accordingly. If they are a write, it will be sent to the node that is marked as the primary. And if it's a read, it will be sent to one of the read replicas. It can really save organizations a lot of time and stops them having to make complex application changes.
Okay, so how does MaxScale know where to send the queries?
Well, MaxScale will monitor the back-end database servers. So there are various things in place from basic health checks, but these
Mhm.
also include disk space checks. It will look at the load on the server, the number of connections it is currently handling, and it also can track the individual transactions. So a read would only be sent to a read replica if it has processed a transaction, for example.
Okay, so let me think. If a server has gone offline, or if it's no longer available for maybe maintenance or hardware failure, what happens exactly?
Well, the monitoring in max scale will redirect your transaction to another server that can handle the request. So,
Mhm.
depending on the topology of the backend servers, will depend on the behavior. But the important thing is that in the event of a failure of a server, your application will not know. It will carry on reading and writing to the underlying database cluster.
Mhm. Okay, that sounds pretty cool. What else can MaxScale do?
Well, since MaxScale can understand what is going through it, we can do many things on the way to protect your data and server. We can filter out queries. We can block users. We can help protect with security. Um,
Mhm.
MaxScale can also cache the results if you require that of your queries. And when we're returning the results of your query, we can do things like result limiting or data masking.
Okay, hold on a minute. So what exactly is data masking, Kester?
Well, that's a great question, Marta. Data masking is where we hide sensitive data. So you might need to have credit card numbers or bank account information or other sensitive data on your servers. So MaxScale can mask that data. So that means that if someone selects the data, they will never see the actual data.
Okay, that sounds like a great security feature in order to help protect your data. So can you tell me a little bit more about the failover?
Well, implementing MaxScale provides you with automatic failover.
Mhm.
No more downtime in the event of database server failure. A new server will be elected to be the primary by MaxScale, and this saves hours of manual process. Any connections will be automatically migrated to the new primary. The session restore process in MaxScale will restore the session to its previous state on the new primary, and then the transaction replay will replay the transaction on the new primary server after its promotion.
Okay.
And this helps to avoid loss of data and, most importantly, no error message or timeout for your client or your application.
Okay, wow. So really you could lose a database server, your application never knows about it. That sounds quite great. Is that all MaxScale can do?
No, not at all. There are many other things, not just to do with scaling or high availability. Max Scale not only talks MariaDB SQL, it also has a protocol to allow it to speak what we call NoSQL. So this means that your document data, or what some people might call JSON, can be stored directly in MariaDB.
Okay, so this can be like a replacement for a Mongo database, for example.
Yes, exactly that. We will store your JSON data within MariaDB, and
Mhm.
this brings with it many of the benefits that we provide to you within MariaDB.
Okay. Is this what people usually call Kafka?
Well, not quite, because our Kafka importer is something different. This allows you to stream data in and out of your MariaDB analytical cluster.
Okay, this is a new cluster. Hold on. So what's an analytical cluster?
Well, people might call this a data lake or a data warehouse or big data. There are many names for it.
Okay, so you mean like a column store?
Yeah, so column store is our analytical storage engine. And with MaxScale in front, you can build a highly scalable and reliable cluster to store
Mhm.
very large amounts of data.
Okay, I think I'm starting to understand a little bit better. So does this mean that it has to be on the cloud?
Um, Whilst cloud hosting does work well for some people, many organizations are realizing that it's actually not very cost effective, and sometimes they're looking for some sort of hybrid approach instead.
And what exactly is a hybrid approach?
Well, this is where people might run some databases in the cloud for scale and others locally in their own data centers or co-location locations. So MariaDB can be installed and run on both and then seamlessly linked together.
Okay, does this bring high availability with it as well?
Yes, absolutely. So you can have data in different data centers, different clouds, different availability zones. Really, the options are endless. We could say as good as your imagination.
I guess this is where MariaDB Enterprise architects can usually help, right?
Correct. Yeah. So we have training, professional services, pre sales, post sales, and architects able to help you design the most efficient system for your needs.
So MariaDB can run on any cloud, on any server, in many different configurations.
Well, there are some technical restrictions, but yes, pretty much. It can even run in Docker containers or maybe on Kubernetes or OpenShift. Um, Let me show you a standard transactional installation.
Okay. Um, what do you mean exactly by transactional? Is this the big data thing you mentioned before?
No, a transactional database is where most people will store data that is used on a daily basis for running their business.
Okay, so like maybe a website or a bank.
Yeah, yeah, any day to day data. And actually, a lot of people use the standard transactional database for large amounts of data. MariaDB is very fast and very reliable, and it's an enterprise grade product. In fact, a lot of our business these days is people migrating to MariaDB from what you might call legacy databases.
Okay, so like Oracle.
Possibly, but also other database providers.
Okay, okay. Let's not get lost. What about this transactional thing, Kester?
Well, yeah, this is an example of where you can have a cluster of database servers for high availability. This could be using various different topologies, so maybe Galera cluster, asynchronous or semi-synchronous replication, or a combination of things. But importantly, they all sit behind one or more max scale servers. So then your applications, systems, monitoring solutions, etc., all plug in via max scale. And you can also plug in maybe some message queues or serverless processes and your internal users into max scale.
And MaxScale provides the high availability and scalability that enterprise requires, right?
It does, Marta, yes.
Okay, amazing. So, what would an analytical cluster look like?
Something like this. So the analytical cluster, again, sits behind MaxScale, and we would recommend that you have multiple MaxScale servers for high availability. And then plugged into the MaxScale servers, you can plug in all sorts of other services.
Okay, so you mean things like the NoSQL protocol or the Kafka streams?
Yes, that and many other things.
Okay, so in the analytical cluster, do you still get scale and high availability?
Yes, you do. The exact same benefits of MaxScale exist regardless of the back end installation.
So does this mean that it can also run on the cloud?
Yeah, yeah. You can run this at any scale on prem, in the cloud, or some kind of hybrid installation.
Okay, amazing. Well, as you guys can see, the MariaDB Enterprise ecosystem brings with it many different services, including our 24/7 support from our technical team directly. We also offer you training, consulting, architecture, and various tools to help you run your business. If you want to add more advantages to it, you can also add a remote database administrator service, which can help you focus on what you truly want to do instead of all the tedious database tasks that usually takes you endless hours. MariaDB might be open source, but it is also an enterprise system with security, failover, caching, scalability, and high availability that is usually required for your use case. Our pluggable storage engines allow us to provide you with the right infrastructure for your requirements, and this is configurable right down to each individual table, replication, clustering, columnar data, on-prem, in the cloud, or hybrid. So, whatever the case may be for you, we have the solution. We have now come to the end of our presentation. And on that note, I would like to thank you for your time. Thank you for being here. And if you have any questions for me or Kester, feel free to ask now.
Nothing in the chat.
Mhm.
Okay. Well, if there is no questions, we'll end here. So thank you very much for your time.
Thank you, guys. Have a good day.
Thank you both for the wonderful presentation. It was very informative.